So let's say we want to graph f of x equals 2 raised to the power x and g of x equals log base 2 of x on the same plane. So for something like this, we could go through the steps of evaluating that function g at some nice, maybe not so nice values, see what we can do there, think very carefully in terms of reversing exponential things, or more thoughtfully, we can remember that we did 2 raised to the power x earlier on. We did that in the last section, and understand that when we're dealing with inverses, like a logarithm is to an exponential, all we're really doing is flipping the order of information. We're going from talking about x to give g of x to instead have g of x giving x in some sense. So you just take those things that you had for f, flip them over, and you get things for g. And if you want to talk about what that picture is going to end up looking like, well, you can just end up taking your picture for g, or not g, excuse me, f, and to do it in the book way, flip it over the line y equals x, or you can also think about that as being the graph of f just found in the opposite order. So whenever you have to find things like this, you have to find those points to be able to make your picture, whenever you want to get those graphs together, the best way to think about it, the best way to handle it, is to figure out what sort of exponential is going on in the background, describe some things with that exponential, describe easy things with that exponential, and then flip them over to get your logarithm instead, where, again, it all comes from exponential things, and now we're going to get some more detailed characteristics of how these things behave in general for domains, ranges, and what transformations can do.